My name is Shubha. I am explaining about FCFS scheduling, that is first come first serve. Introduction. In an operating system, when many processes are ready to run, the CPU must decide which process should run first. This decision is made using CPU scheduling algorithm. One of the simplest algorithm is FCFS, first come first serve, where the process that arrives first gets the CPU first. It works just like a queue in a ticket counter. Objectives of this project is to design an FCFS scheduler, to implement it using the C, to evaluate its performance using multiple datasets, to check whether FCFS is suitable for real-time system. Overview of FCFS is the simplest non-preemptive scheduling algorithm. Processor queued in order of arrival. The CPU serves the process at the head of the queue until it finishes, then moves to the next. Simple to implement, fair in the order of arrival, but vulnerable to the runway effect, that is long task delayed short ones. Second one is experimental setup. Programming language, here I used C language. Tools used any C compiler like GCC, Toad Blots, VS Code or an online compiler. Here I am using online C compiler. Data set, we used different sets of processes with varying, that is arrival time, rest time, number of processes. These data sets help us observe how FCFS behaves in different situations. Third one is implementation setup. The FCFS scheduling implementation is a simple. Input processes with arrival and bus time. Sort them based on arrival time. Calculate starting time, completion time, waiting time, turnaround time. Print the results in a table. Draw the Gantt chart. The C code follows exactly these steps and prints a clear output table. FCFS scheduling flowchart is start the program, then enter the number of processes, then enter each processes arrival time and bus time. Sort all processes in order of arrival time because FCFS runs the one that comes first. Set current time is equals to 0 for each processes. If the CPU is ideal, move the current time to the processes arrival time. Calculate start time, completion time, waiting time and turnaround time. Update the current time to the completion time. After all processes are completed, display the output table. End of the program. Complete the C code, that is the input section. The user enters the number of processes. For each processes, the program takes arrival time, that is 80 bus time, that is bit. Each processes is given in the processor ID PID. Sorted by arrival time. Since FCFS runs the processes that arrives first, the program sorts all processes based on their arrival time. FCFS scheduling logic for each processes starting time, that is ST, when the CPU begins executing the processes. Completion time CT, when the process finishes. Turnaround time TAT is equals to complete time minus arrival time, that is CT minus AT. Waiting time, that is WT, is equal to starting time minus arrival time, that is ST minus AT. The program also handles a CPU ideal time if a process arrives later. Output table. Finally, the program prints a table showing the process ID, arrival time, bus time, starting time, completion time, waiting time, turnaround time. This gives a clear representation of how FCFS scheduling works. This is the output of the code. When we give the values, arrival time, bus time, then it shows the table. Process ID, arrival time, bus time, starting time, completion time, waiting time, turnaround time, it calculates. Then observation. Fourth one is observation. From the program we can observe waiting time a process waits in the ready queue. Turnaround time, total time from arrival to completion. Response time in the FCFS, response time is equals to waiting time. No content switching because FCFS is non-preemptive. Performs highly depends on arrival order. We notice that processes with long bus time at the beginning increases the waiting time of the all other processes. Fifth one is comparative evaluation. We tested FCFS on three datasets. For each datasets, we compared average waiting time, average turnaround time, CPU behavior. Here, like for example, dataset 1 average time is low, average TAT is low, content switches are 0, then remarks short burst performance, that is good. And second dataset is average waiting time is high, average turnaround time is also high, content switches are 0, then remark is launch of first effects, that is strong way. Third dataset is medium, average TAT, that is turnaround time is medium, content switches are 0, then remarks are mixed processes. Short analysis. FCFS performs well when arrival times are spread out and burst time are small. FCFS performs poorly when a long process arrives first. Due to high waiting time and no priority, FCFS is not suitable for real-time systems. Finally, in this project, we design and implement an FCFS, that is first come first serve scheduling simulator agency. The results showed that FCFS is very simple to use and easy to implement because it follows a basic first come first serve order. However, our observations and data sets comparison proved that FCFS can create a waiting time when a long processor arrives first, causing the runway effect. Since FCFS does not prioritize urgent tasks and gives no preemption, it is not suitable for real-time system where quick response is required. Overall, FCFS works well for simple non-critical workloads but performs poorly for time-sensitive tasks. Thank you.